Do you feel the vibes?
Okay, hello everybody. I hope you all had a wonderful break and you are feeling restful. I know the break was way too short, but alas, here we are. So we might as well start chapter 2. The trig part is over. We are now going back. We're going to start with chapter 2, like I said. Okay, so let's get to it. Okay, so the first thing we're going to do in chapter 2 is what we call synthetic division. Synthetic division is a shortcut method that we use to divide polynomials. Okay, and it's used only in the special case of dividing by a linear factor, right? So only when you're dividing by a linear factor, meaning, there is an exponent of 1. Okay, so let's see here which of these cases would allow us to use synthetic division. So in this case, I have this divided by this, not linear, right? This bottom one is not linear. So no, we can't use synthetic division on this. This one, I'm dividing that monstrosity by a linear term. So yes. This one, no, because x squared is not linear. This one, I have 3x to the power of 1 minus 2. So yes, possible. Okay, so what is synthetic division? Well, here we go. We want to divide this polynomial by x plus 1. Okay, so for your first step, we're going to set up the synthetic division. What we do is half of a rectangle like this, like a little chart. And before you even start, you want to make sure that all of the exponents are present and in decreasing order. What I mean by that is the following. Take a look at this polynomial, x cubed, blah, blah, blah. This starts with an exponent of 3, right? Starting with 3 and going down, you should have all the exponents there. So for example, exponent of 3, 2, 1, 0. No missing exponents and in decreasing order, so we're good to go. Okay, so that's step 1. Step 2, before we do that, we haven't set it up yet. To set up the synthetic division, what we want to do is we want to take the coefficients of this. Okay, so the coefficient of this first term is 1, so I just put 1 there. The next one is -3. The next one is -2. The next one is +4. Okay, so that's what goes inside. So what goes outside? I take this term, always set it equal to 0 and solve for x. So now I get -1 and I put that here. So now my step 1 is done. Okay, step 2. Bring down the leading coefficient to the bottom row. Just bring that down here. Done. Okay. Multiply this value just written by the outside number, by the red number. Anything that makes it below this line has to be multiplied by that red number outside. So 1 times -1 is -1. Next step is, we did this, add the column created in step 3. So we're going to add this. It becomes -4. Oh, -4 made it over here. Multiply by -1, +4, add 2. Oops, multiply this by the red number, -2, add, I get 2. Okay, we're done. So now we don't want to write out the answer. Okay, so how do we write out the answer? Remember what we're doing is dividing. Well, when you're dividing, you normally or usually you get a remainder. This last term is always the remainder, that last number. Now, we're going to write the quotient, the answer. Okay, so here's a question for you. Look at the initial polynomial, this one here, x cubed minus 3x squared and so on. What was the highest exponent there? 3. When we divided, that process reduced the exponent by 1. So instead of x cubed, now it became x squared. So check out what happens. This gets now an x squared, x to the 1, and nothing. So when I write this out, I get 1x squared minus 4x plus 2, and I have a remainder. The way I write the remainder is plus 2 over that term x plus 1. And that is how we do synthetic division. Okay, let's do another one. Synthetic division of this. Okay, so let's take a look at the exponents. I have x to the power of 4, 3, oh my god, missing the 2, 1, 0. Because the x squared term is missing, we have to write a 0 in its place. So when I do this, the coefficient is 1, then 4. I'm missing the x squared term. I put a 0 in its place. Then I just continue as normal. Negative 12, negative 9. Okay, I get x plus 3 equal to 0. X equals negative 3. Okay, now, first one comes down for free. Whatever makes it down there gets multiplied by the negative 3. You add, multiply by the red one. You add, multiply by the red one. You add, multiply by the red one. You add, oh my gosh, we got 0 for the remainder. That's fine. So now, what had we started with? X to the 4. Reduce it by 1, you get x cubed. So I have x cubed plus x squared minus 3x minus 3. That's it. No remainder, no remainder. Okay. Now, yet another exception to the rule. This time, the binomial, this has a factor of 2. Oh my gosh, what are we going to do? We're going to divide both polynomials by 2. Divide by 2, divide by 2. Okay, can we just write the divided one here? So when I say divide by 2, like you're going to divide literally every single term by 2. Okay, like this. Okay, so the first term becomes x cubed minus 3 over 2x squared minus x plus 3 over 2 divided by x minus 3 over 2. Okay, now, once you do this, this top one no longer exists. Okay, it's all about the bottom one now. Okay, so why don't we go ahead and do this? Okay, exponents, 3, 2, 1, 0, all there. Okay, so coefficient of 1, negative 3 over 2, negative 1, positive 3 over 2. Here, x minus 3 over 2 equal to 0. 3 over 2. Okay, fabulous. 1 comes down. Multiply. Add. And I get 0. Multiply by the red number, you get 0. Add, you get negative 1. Multiply by the red number, negative 3 over 2. When you add these two, you get 0 remainder again. Okay, I started with x cubed. Now I have x squared. 1x squared plus 0x minus 1. But we don't like the 0x, so I just write it as x squared minus 1. Okay. So, All right, so what did we, in algebra, right? We talked about zeros. And in there, we said a zero of a polynomial function is the x value where the graph crosses the x-axis. So for example, if I have a graph that looks like this, wherever all of the x values where the graph crosses the x-axis are the zeros of the function, right? Because the y value is 0 there. The function is 0 there. So those are zeros. A zero can also be referred to as a solution, a root, or an x-intercept. Okay, moving along from that. There are two methods to find the value of a function at a given point. These are direct substitution and synthetic substitution. Okay, let's talk about direct substitution. So look at what I have. F of x is equal to this. We want to find f of 2. Okay, we directly substitute 2 in there. So f of 2 is 2 times 2 squared plus 9 times 2 minus 35. This is 2 times 4 plus 18 minus 34. F of 2 is negative 9. Okay, f of negative 7. 2 times negative 7 squared plus 9 times negative 7 minus 35. This is 98 minus 63 minus 35. So f of negative 7 is equal to 0. Now the question asks, are any of these zeros of the function? Well, when we plugged in 2, we got negative 9. But when we plugged in negative 7, we got 0. Because we got 0 when we plugged in negative 7, then yes, x equals negative 7 is a 0 because f of negative 7 is 0. Okay? Just like what we said here. The y value at that point is 0. That means that x equals negative 7 is called a 0 or a solution of the equation. So that was by direct substitution. We can do the same thing using synthetic substitution. Notice we have the same equation here, and we want to find f of 2. So how do we do that? Well, it's synthetic substitution, so we set up a synthetic division situation. Here, I put the coefficients 2, 9, negative 35. Okay, outside, I put this number. This time, there's no solving, there's no setting equal to 0. You just put the number as is. 2 becomes 2, not negative 2, as is. Okay, first number comes down for free. Everything down here gets multiplied by the red. We add 13. We multiply 36. I'm sorry, not 36. 26. You add, you get negative 9. That is the remainder. Okay? Oh, but wait. When I did f of 2 before, what did I get? Negative 9. Oh my gosh. This remainder must be the value that we're looking for. So I just say f of 2 is negative 9. Okay. Now let's do this one. F of negative 7. So here, I put the coefficients 2, 9, negative 35. Negative 7 as is goes here. 2 goes down for free. Multiply negative 14, get negative 5. multiply, I get positive 35. When I add, I get 0. Okay, so now when you do synthetic division, how can you tell if any of these are zeros? Well, in this case, the remainder is 0. So that's how we can tell that is 0. Okay? All right. We're actually going to stop here today because after I printed all of the packets, I realized that the juniors have a bonding day on Wednesday, which means we're not going to have class. So I had to reorder everything. So I'm going to take a couple of things out of the packet. For that reason, we are stopping here today. Your homework is a handout, which you will or should be given. And it takes into account where we stopped. So you do the homework for tomorrow, and we will just get back to it next class on Tuesday. Okay, have a wonderful rest of your day, guys. Bye-bye.
Do you feel the vibe?